Hello, today we're going to be looking at homework 7, part 1, which says, starting from Roulette's law for ideal solutions, derive and explain the equations to be solved to determine the bubble and dew point temperatures of a binary mixture. All right, so the first thing we want to do is we want to write out Roulette's law. So we have the mole fraction of component 1 in the liquid phase times the saturation pressure component 1 is going to be equal to the mole fraction of component 1 in the vapor phase times the total pressure. And it'll be the same thing for the second component. So component 2 equal to the mole fraction of component 2 in the vapor phase times the total pressure. And then we also know, since we have mole fractions, we know that x1 plus x2 is going to equal 1, and y1 plus y2 equals 1. Okay, so so first let's solve for the bubble temperature. So bubble temperature is the temperature at which, at a given pressure, bubbles will begin to form in the solution. So in the bubble temperature, if we're given our pressure and we are given our mole fractions, so we get x1, x2, y1, and y2. So to find the bubble temperature, we do x1 times P1 sat plus x2 times P2 sat is going to equal the pressure. So if we're given pressure and we're given x1 and x2, and P1 sat and P2 sat are our saturation pressures, and they're going to be based off the temperature. So in order to solve this equation, we would need to continuously plug in numbers for our temperature that would make this equation true. And to do that, you'd need to use some sort of solver that could do that for you, like in Python or something. So that is our bubble temperature calculation. And now for our dew point temperature calculation, we are also given pressure, and we're given y1 and y2. So now we want to solve for x1 and x2. So we'd rearrange our Roulette's law equations and do x1 is going to equal y1 p over p1 saturation, and then oh shoot, what's that? Okay, and then x2 is going to equal y2 pressure and saturation pressure of component 2. So now what we can do is, since we've solved for x1 and x2, we can plug those into this equation. So we get y1 pressure plus equals 1. So in this, we are given y1, y2 at our pressures, and again we need to, our saturation pressures are determined off temperature. So we would need to again use a solver to test a bunch of different temperatures and see which temperature would make that equation true. And that is homework 7, part 1.